Hello. Today we'll be going over conjugated donor-acceptor polymers. First, we'll be briefly going over what polymers are, then what it means for them to be conjugated, and finally the donor-acceptor system. Now, polymers, I like to think about as long spaghetti noodles. Here, more specifically, they are chains of repeating covalently bonded monomer units. Here I've drawn polyethylene. We have carbon covalently bonded to carbon, covalently bonded to carbon, etc., 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 forming our polyethylene. This is described by our ethylene monomer unit. There are different covalent bond types or hybridizations. We have sp3, sp2, and sp. sp2 and sp will be the ones we'll be focusing on. sp2 is defined with double bonds and sp with triple bonds. sp2, we have three sp2 hybridized orbitals and one available p orbital. Same as well for an sp, we have two sp orbitals and two p orbitals. These p orbitals allow for the formation of our pi bonding here and dual pi bonding here from our two p orbitals for sp right here and right here. Well, this is cool, but how is this interesting? Well, because of the rotational lock that pi bonds have, p orbitals will therefore tend to, or pi orbitals will tend to have form electron clouds. Here, if we look at benzene from the side, we'll see that we'll have these two pi orbitals stacked and or aligned with one another. And these will allow the delocalization of our electrons, having an electron come from here, for example, all the way to here. Examples also will be for conjugated polymers. Let's say we have an electron here. Well, it might be able to travel all the way here. Why is this interesting? Well, this allows for electrical conductivity. Here we also have some other typical conjugated polymers, which are polythiophene or P dot, and more recently P dot PSS. Now, how are we able to allow this transfer of electrons through the p orbitals? Well, we need to excite our electrons from our sp2 to our p orbitals, from the HOMO to the LUMO. And to do this, we have to overcome the band gap barrier. Well, how can we minimize this? Well, we can try to minimize the band gap to allow an easier flow of electrons from sp2 to p. To do so, we have the donor-acceptor system, in which a polymer will have a donor section and an acceptor section. The donor section will be noted by higher orbital energies with our higher HOMO and higher LUMO, while the acceptor will have lower LUMO and lower HOMO. This will create a smaller band gap if we compare simply to here. Our donor section, to allow for this higher energy, we will introduce electron donating groups. This will push our energies up. For the acceptor units, we will instead put electron withdrawing groups, which will push our energies down. Typical electron withdrawing groups include nitroxy groups, carboxyl groups, etc., etc., electron donating groups, your amines, thiophenes, things you can most likely learn in your typical organic chemistry class. Now, examples of donor-acceptor conjugated polymers, again, we have our sp2 noting, very important, are shown below. And I would like you to find which sections of said polymers are donor and which sections are acceptor. And I'll let you pause the video, and here are the answers. I hope this